calculations. So let's start with this first problem here. And they're telling us that a small hole in the wing of a space shuttle requires a patch that's 20.7 square centimeters. So we don't really need to have a picture for this, but I'm just going to draw. I've got a little patch here, and the area is 20.7 cubic centimeters. So there's two parts to this problem. The first part asks us to figure out the patch's area in square kilometers. This is a problem I've had in the past. It was from a previous textbook. I don't love this problem because I don't think it has a lot of practicality. Nobody's going to measure the area of a patch that's, 20 cubic centimeters in cubic kilometers. It's just not reasonable. So keep that in mind as we work through this. We're going to get weird looking numbers, but that's because we're asking to basically take a patch that's maybe the size of like a large Band-Aid, and then we're going to say how many square kilometers is that. So it's going to be a weird number, but the strategy is still going to be the same. So in part A, it says, what's the patch's area in square kilometers? So when I make a roadmap, I'm going to start with information that I know, and then I'm going to ask, what are the units that I want to get to at the end? And I'm so used to writing volume, I apologize here. These are areas, so they are squares. So some of the earlier problems that we did, and actually most of the problems that are in your textbook as kind of additional problems, are going to be one-step unit conversions, where you basically could go from the unit that's given to the unit that you want to get to. I've told you guys you're going to have somewhere between 3 and 5 steps in your unit conversions. So even these ones that we're going to do at the beginning here are a little bit simpler than the ones you're going to see in tomorrow's class. But let's walk through, if we wanted to do this, how we would set up our roadmap. This is not a one-step process. I don't know a direct connection between kilometers and centimeters. So what I need to do is I need to go from centimeters and walk to something that I do know. Well, I do know walking to meters. And what I'm going to do here as I make my roadmap is I'm going to remind myself of the factor difference between these different things. This is what we call those prefix conversions. So this is going to be a prefix conversion. This is something that you will have to know, right? There was that table that showed all of those different, what we call unit prefixes. So this is all those, milli and micro and kilo and things like that. So I know that this is a factor of 100. We'll talk in a minute about how we actually use that factor of 100. But now I'm at meters, and then I know I can go to kilometers, and I know that that's a factor of 1,000. So one of the things I want you to remember is just what is the factor that we have there. Centimeters to meters is a factor of 100, and then meters to kilometers is a factor of 1,000. Now we're not always going to be, in this case, we're not multiplying by 100 and then also multiplying by 1,000. I just want you to have that ratio in your head, and we'll see how we kind of execute that in just a second here. So this is my roadmap. I have 2 steps to my roadmap, so that means I'm going to have 2 unit conversions that I need to use. So let's start with the information that's given. Now we're ready to put in our numbers. So I've got 20.7 square centimeters. Now I need centimeters to go away, and I'm going to walk to meters. So that's how I'm going to set this up. Now this is where I know it's a factor of 100, but I need to make sure I put the 100 in the right spot. My 100 is going to go down here, and my 1 is going to go up here. This is a classic place where students make mistakes, is they put the 100 in the wrong spot. So one of the things that I always tell people to remember is remember big, little. Okay? We always want to have the bigger number with the smaller unit. So hopefully you remember that a centimeter, remember we've got our little sugar cube is a centimeter is smaller than a meter. So meter is the smaller unit. I'm sorry, centimeters is the smaller unit. So that's the little unit. So it gets the big number. Okay. The other piece that's very important with this is because I've got this square that's right there, I have to make sure that I square this relationship. So that's going to be a square there. Now I can see that my units of centimeters squared are going to go away, and I'm left with units of meters. Now my next step that I had here was I knew I wanted meters to go away, and I want to be left with kilometers, kilometers. Now again, I know that it's a factor of 1,000 difference, but I have to make sure I put my 1,000 in the right spot. Now in this case, right, I know that there's 1,000 meters in a kilometer, okay? So I'm going to put my 1,000 on the bottom and my 1 on top. So for this problem, I'm actually dividing by 100 and dividing by 1,000. And I'm actually going to be doing that twice here because I have to make sure that those units are squared. Now my meters squared are going to cancel, and I'm left with the units that I want for my answer, which are kilometers squared. Now this is one of these problems. You want to make sure that you try this on your calculator, that you get the same answer on your calculator, because how you enter things in your calculator can make a great, it's really important to make sure that things work out with getting the right answers. So to that end too, I have posted on our class teams page. If you have ordered the calculator that I sort of put a link out for, and again, you don't have to have that calculator, but one of the things I want to highlight is you should start learning how to use the EE key. So I'm just going to kind of put a little reminder here for your calculator. Use the EE key. And if you're not familiar with how to use the EE key, okay, watch. It's like a little 3-minute video. Watch to make sure that you know how to use that on your calculator, because we're going to be doing a lot with scientific notation. And so you want to make sure that you're entering those quantities in your calculator correctly, because if you're not, you're likely to be off by a factor of 10 or 100 or 1,000. The answer to this problem is 2.07 times 10 to the minus 9th square kilometers. This is a very, very small number, but that should make sense. I mean, think about what a square kilometer is going to look like, right? Maybe a mile is easier for us to think about, but we've got a mile in our length and a mile in our width, and we've got all of the land that would be in that area. And now imagine taking your little patch that's the size of maybe a playing card and setting it in the middle of there. It's going to be a very, very small amount of that large area. So always have kind of your logic hat on and ask yourself, does this make sense? Okay, so before I move on here, and this is, a great place, we have 17 people here, which is great, but I certainly want to give you guys an opportunity to ask questions. This is the perfect place to ask questions because we sort of have an open-ended amount of time. So I'll pause for a second here and let you guys ask questions if you have them. All right, hopefully that means everybody's like, I got this, okay? Now, even, a fair question is, Dr. Prenny, I understand when you do it, but I don't know if I'd know where to start this problem. That's a fair question too. So, I'll try as we go through these problems to kind of highlight how I know where to start. But if you're tomorrow or Friday, whatever it happens to be that you're taking the quiz, if you're trying to figure out where to start, take all the pieces of information that's given. Anything that is something equal to something else is a unit conversion piece. And literally imagine trying to kind of put these puzzle pieces next to one another so that you can have everything line up so that your units cancel like we did here. These line up and cancel. These line up and cancel. And I think I've told you guys this in class. I can't tell you how many times I have a situation where a student maybe doesn't even understand the chemistry really well, but because they're good at unit conversion, they can put these pieces together and get the right answer. So let's do this next part here. This next part says, if the patching material costs $3.25 per square inch, what is that patch going to cost us? Oh, sorry guys, my mother-in-law was trying to call. Can you guys still hear me? Are you still there? All right, sorry. I have to tell my mother-in-law, she knows I'm in class, but let me send her a text message. I am in class right now until 7. Please do not call. It kicks me off my Zoom session. Thanks. I should say thanks. All right. So I think I need to jump back on here. I need to start sharing this content again. All right, so back to how much is our patch going to cost here? All right, so we know that the patch costs $3.25 per square inch, and we know that we need a patch that's 20.7 centimeters squared. So I'm going to have the same starting point. I know that I've got a certain size patch in centimeters squared, and I need to know dollars. Well, the piece of information that was given to us has dollars in it, but it doesn't have centimeters in it. So I am, again, not a one-step problem. So this is not one step. Remember, anytime you want to ask, anytime I have one of these arrows that shows this and this, I must have a unit conversion that has both of these parts with it. That's how I know to use that unit conversion. I don't have a unit conversion that has centimeters with dollars, so I can't use anything in one step. But if I make a roadmap, what I do know is I have a way to get, and sometimes you can work a little bit backwards. Let's show you how you do that with this problem. Well, I do have something that has dollars. The piece of information that I know that has dollars is this guy that's given. So that's going to get me to inches. Now I know I can relate inches to centimeters, just like I did in my previous kind of step, but this is going to be a special unit conversion. It's going to be one of those English to metric ones. Those are ones that I'm going to give you. All right, so I kind of worked backwards from this. I guess this is not unlike if you were in a maze or something like this and you had to figure out how to get out of the maze. Maybe you'd figure out how to do it backwards. Or if you ever had a puzzle, like a maze puzzle that you had to do as a kid, some people will start from the end and try to work towards the beginning. You can do that, but when we put this together and kind of do the math, now we have to start from the pieces of information that we know. So in this case, I know that I've got 20.7 square centimeters. I'm going to highlight here, I probably should have written this up top here. Going from inches to centimeters, this is what we call an English to metric, and I'll abbreviate those when I'm kind of labeling what I do here, an EM conversion. These will always be given to you. You don't need to know these, and it's not written as part of this problem, but in this case, 1 inch is 2.54 centimeters. So that's something that would be provided for you. So now that we know that information, let's actually go ahead and start putting our pieces from our roadmap together. So again, I wrote my roadmap starting from my end point. So now I'm going to execute it by starting in this direction. So I know, again, I've got a patch that's 20.7 square centimeters. I want to walk between centimeters and inches. And so I'm going to look at the unit conversion that was provided, and the 2.54 goes with the centimeters, 1 goes with my inch, and I have to make sure to square that. Okay. Now I know I have inches squared, and I know from the piece of information that was given to me in the problem, I've got 3.25 in terms of my cost, so $3.25 for every 1 square inch of patch. Go through that math, and then we're going to end up having $10.43 is going to be the cost of our patch. So I'm going to go ahead and do what I ask you guys to do when we do problems like this. Go ahead and box your answers. Make sure your answers always have the right number of significant figures and the right units. So I'll give you guys a minute to finish writing and then see if you have any questions on this one. And maybe Let me know in the chat. I'm going to open up the chat here. Just give me a number on the scale of 1 to 10. With this problem, how do you feel things went for you on a scale of 1 to 10? 10 being like, I totally got this. I actually had it, Dr. Peroni, before you did. I know how to do this one. 1 is like, I am completely lost. I really have no idea what to do. And I'm loving that I'm seeing a lot of 10s, so that's really good. 10s and 9s are good. And it's okay to be vulnerable and be like, I haven't had chemistry since, or any science since 9th grade, so I need a refresher. All right, I'm seeing a lot of 9s and 10s, so that's really good. So let's go on and do this one right here. What I'm going to do is I'm going to let you guys try this one. This is similar kind of a problem. I'm going to let you guys try this one on your own here. I'm going to give you about 5 minutes to work through it. There is a couple of pieces of information that would be normally provided for you, so I'm going to let you know what those are. A piece of information that early on is going to be given to you, but in future will be cubic centimeter is equal to liter. This is an important unit conversion because it's going to allow us to kind of walk between volume that's measured in length, like a centimeter, and volume that's measured in a liquid measure, like a milliliter. So I'm just going to kind of highlight this here. This is going to be an important one that I am going to want you to know in the future. I will give it to you when we start out here. But why this is important is we can change volume that we have in terms of a length measurement to volume that we have as a liquid measure. So sometimes we can do, volume by actually physically measuring the length, width, and height. Sometimes we're going to have volume that we're going to have with typical volume measurements, milliliters or ounces or things like that. So I'm going to give you guys a minute to try to work through this problem. I'm going to write the answers that you should get for each of these, and that way you can check to see if you were right. And then we'll reconvene and we'll chat about it in a few minutes, and then I'll probably write the answer fairly quickly. So I'll plan on reconvening with you guys about 6 o'clock. We'll see where you guys are at. Feel free if you want to. I'm going to just mute my video for a second. But if you have questions, feel free to just unmute yourself and ask a question if you want some guidance. All right, how we doing? Do you guys want some more time? I'm totally fine giving you some more time if you want to work on more time. If you'd like more time, just type in the chat time, and then we'll give you some more time. Otherwise, I will start kind of going over the answer. All right, I am not hearing that anybody is ready. You guys have the answers that are up there already. I'm going to kind of try to see all you guys here for a second. Why don't you give me a thumbs up if you got those answers. Oh, bummer. I can't. Alexa's like sort of sideways. I got, okay, you can give me a thumbs up too with the little thumbs up icon. All right, well, let's go through this. Trying to get all these windows out of the way so I can actually see my screen here. Okay. Do me a favor in the chat, kind of, if you didn't get the answer, do you feel like you got part way? Just kind of give me a 1 to 10 number again. I'll look at those in a minute, but I'm curious how you guys feel like you did. So let's go ahead and start with this this first part here. So part A, and again, I'm always going to start with trying to give us a little roadmap here to help us kind of sort out what's going on. We are given information of cubic meters, and at the end of the day, I want to get to cubic millimeters. So maybe you might know something direct for micrometers to millimeters, but if you don't, we can go like this. All right, I've got micrometers. Getting back to my base unit of meters, that's going to be a factor of 10 to the 6th, a million. Sorry, I gotta fix you guys here. You're all over my screen. There we go. Now I can see. All right, so I know that I've got a factor of a million, and then I can go from meters to millimeters, and that's a factor of 1,000. Okay, so you might know, maybe because you've kind of practiced and you can see that chart in your head, I've got my base unit of meters, and then it's 1,000-fold difference to go to the milli, and then another 1,000 to go to the micro. So going between milli and micro is really just 10 to the 3rd. So you might know that, and maybe you do know that this is just a one-step problem. But if you didn't, always go back to the base unit. So as you're studying these, you do need to know these prefix conversions. So you need to know milli, micro, pico, nano. That's kind of getting to the small, small, small scale. And then you need to know, even in between there, you need to know deci and centi. So deci is 10-fold. So let's go ahead and do that if you didn't know these already. So let's talk about our base unit. And then we're going to go to deci, centi. So each of these is a 10-fold difference. And then milli. So each of those represents a 10-fold difference. And so this is a 1,000-fold difference going to milli. Okay. Then we go to micro. That's another 1,000. Then we go to pico, and then nano. And I've got these backwards. I paused for a second. Nano is first. Sorry, guys. And then pico. So going between base, we've got deci, centi, milli. Those are all off by a factor, or I shouldn't say off. Those are all scales or differences of a factor of 10, such that base to milli is 1,000. And then everything else is 1,000. Milli to micro, micro to nano, nano to pico. Those are all 1000s. Now let's go kind of up here, and we really don't tend to see anything bigger than kilo. So again, this is going to be 1000 difference. So anything with deci, centi, milli, micro, nano, pico, those are 6 that we need to know. We keep getting smaller, smaller, smaller. And then the one that gets bigger is going to be base to kilo. Okay, so let's go through and then put our information in, because now I've got these pieces of information. This is going to be one I want to make sure that you put these values in your calculator to make sure you get the right thing. So if you didn't get the right answer, maybe that's why. So we've got 2.56 micrometers cubed per cell. I'm going to make micrometers go away, and I want to get to meters. So again, I know this is a factor of a million. A million is 10 to the 6th. I just have to figure out where's my 1 go and where's my 10 to the 6th go. Micro is my small unit, so it gets my big number. So 10 to the 6th goes with micro. My 1 goes with my meters, but I do have to make sure I cube everything. So it's actually a million and a million and a million in my denominator, right? This is going to be a little bit of some crazy math, but I'm going to show you something we can do to sort of simplify this in just a second here. Now I want meters to go away, and I'm going to go to millimeters. In this case, it's going to be 1000 different. And now I know that my 1000 goes on top. 1000 is 10 to the 3rd. And then my 1 meter goes here. But again, I've got to cube this. All right, so there's a lot of zeros going on in this right now. So I'm going to show you a little trick, and maybe this is something you've learned with math before, right? Let's figure out what this really is, this first one, right? This first guy, if I cube 1, that doesn't change the value of that. But if I cube 10 to the 6th, does it make sense to everybody that this is 1 over 10 to the 18th? When we do exponents, when we kind of cube or square anything in the exponents, we multiply those exponents together. So it's going to be 6 times 3, which is 18. And then what I've got over here is I've got 10 to the 9th in my numerator. Everybody good with that? Now I've got 10 to the 9th in my numerator, 10 to the 18th in my denominator. What I really can see is that this is 10 to the 9th that's left in my denominator, right? If I've got kind of a division of both of those, I can subtract my exponents. Okay, I'm going to be left with 10 to the 9th in the bottom, which is really the same as 10 to the minus 9th, kind of as is. So we'll put these pieces together here, but really we didn't do anything to the value that we had here in the beginning. We're still going to have that 2.56. We just changed the zeros that we have. So putting all of this together means we're going to keep that 2.56. And now this is times 10 to the minus 9th. Go through, cancel my units. Micrometers cancels, meters cancels. I'm left with millimeters cubed. Okay, so let me look. Nobody wrote anything in the chat. Tell me in the chat, like, where are you at with that problem? Like, if you were good with it, tell me I was good with it. If you weren't good with it, again, it might be something you're good with now, but I want you guys to kind of ask questions about maybe where you got stuck, or feel free to offer that up, because it's probably a space where somebody else got stuck too. All right, Vinny, I'm going to put you on the spot a little bit. You said 5. Talk to me. What's going on with your 5?
Well, I didn't know how to start it at first.
Okay.
But after you kind of started it, I wrote the stuff down, like your like measurements and stuff. But if you're going from, where are we going? We went from micro to milli. I don't get how you got smaller.
So we actually going from micro to milli. So are you saying when I made my roadmap?
Well, I'm looking at on like this chart, like it says micros 1 then 10 to the -6th, and then millis 10 to the -9th. So, or 10 to the -3rd.
All I'm showing is I want you to know the factor difference that these are with one another. Because whether it's getting bigger or smaller depends on whether you're going down or up. I don't know if that made sense or answered your question. So you're right. When we go from centi to milli, this is getting smaller going down here like this. So we'd actually be dividing by 1,000 going that way. But I always think it's too easy to get confused. Am I supposed to multiply or divide? Like, what am I supposed to do with that factor? So that's why I always like just use it as a unit conversion, because that will tell you whether you're dividing by it because we're going to something, we're going to a unit that's, in this case, when we went to meters, we went to a bigger unit. So we were going to end up with a smaller number, or we need to multiply. So I don't know if that answers your question, Vinny, or if it made it more confusing.
It helped a little bit.
So the idea is I want you to remember the factor difference that we have between milli, micro, nano, pico. And again, I could have made this a little bit more complicated too, to say if we go from our base to milli, it's 1,000. If I go from base to my micro, it's 1,000,000. Going from my base to nano, it's 1,000,000,000. So you can also remember those, right? Because that way you don't have to go through those individual steps. Other questions? Vinny was the only one who told me, he's like, I'm a solid 5. Where's everybody else? How did you feel about this problem? Give me a number. Okay, Amber and Abby were 8s. So Amber, tell me, like, so what was an 8 about it? What was a little bit fuzzy?
At first I just had trouble remembering like which part gets the bigger number, but like your big little thing helped a lot.
Good. How about you, Abby? You had an 8 as well.
Well, the only thing that I had trouble with was like remembering like the 10 to the 6th.
So, and the biggest thing I want to make sure that you can put this in your calculator, because it's totally a common mistake that people make, is they'll put in 10 and then they'll put the E and then they'll put 6. If you do that, that means 10 times 10 to the 6th, which is really 10 to the 7th. So I'm going to write that down and I'm going to kind of highlight it here just to make sure. I'm going to put it in a little box down here. If you've got 10 to the 6th that you want to put in your calculator, what you'll type in is 1 EE6. You do not want to put in 10 EE6, because what that is 10 times 10 to the 6th, which is really 10 to the 7th. So this is a common place that students will sort of be off by a factor of 10 in their problems, is when they're entering things in their calculator, particularly if there's not a number. So when we have 10 to the 6th, it's really 1 times 10 to the 6th, which means you type in 1, you'd use EE, and then the number 6. So make sure that you're good using your calculator. Who else? So Anna, you had an 8.
Mine was the same thing as what Amber said, like just remembering how to like convert from micro up.
So yeah, this is just, and I don't like a lot of memorization in class. Unfortunately, we do have a skill we're doing right now with what we're doing in class with naming. That's just something, and I'm working actually, I was working today on putting flashcards together for you guys to sort of help with studying that. We'll have a lot of time to practice both tomorrow and Friday in class after we've completed the quizzes for the groups that are in person. But this is one of those things, if you just wanted to have some flashcards or something that you had that helped you remember sort of how they relate to a base unit, or that you could stack them in order like I kind of made on this little chart here, that can help you. All right, so let's work through this next problem here. Let's do the B version here. Now it says, what's the volume of 10 to the 5th cells? So if I had 100,000 cells, what would the volume be? I know what the volume is here. So again, this was the volume for one cell. So now I want to know what's the volume for 100,000 cells. So it wouldn't be a problem if you started with, you know, the same 2.56 times 10, if you wanted to start with 2.56 micrometers cubed, but I'm actually going to use the answer that we got from A as a place to start. So I'm going to say well, let me write my roadmap first. I always said, let's do that. So let's imagine that we start with the units that we got from our last problem. I've got millimeters cubed, okay? I know that I can go to centimeters cubed because I know that that's a factor of 10 that's different. And now I'm going to use that magic unit conversion that's right here to allow me to change between volume with length to volume with a liquid measure. And then I can go to liters because I know that that's a factor of 1,000. So that's my roadmap that's going to take me through this problem. Now there's one other thing that we're going to have to figure out, and I'm going to show you that kind of at the end. And again, I'll show you that if we keep all of our units with everything, it'll remind us that we didn't use a piece of information. So let's say we've got 2.56 times 10 to the minus 9th millimeters cubed is for one cell. I'm going to get that in terms of liters for one cell. And now again, I know I've got millimeters and centimeters. I need to make sure to put my 10 in the right spot. I know millimeters are smaller than centimeters, so that smaller unit gets the bigger number. Now in this case, I need to make sure to cube things again. And now I can use my special magic. It doesn't do anything in terms of math because it's a 1 over a 1. And now I've got 1,000 milliliters in 1 liter. Now if I check my units here, millimeters cubed are going to go away, centimeters cubed goes away, milliliters cubed. I'm going to have the volume in liters for one cell. And this is kind of the first time we maybe have really seen this. I need to make sure to multiply by 10 to the 5th cells. Now this might feel a little bit strange because we've been doing so much where we're multiplying things that have a numerator and a denominator piece. That's okay that this piece doesn't, because we want to have an answer that has just one unit in it, liters. If we stopped without doing this last little piece, we would have had units of liters per cell. I don't want to know it per one cell. I want to know it for 100,000 cells. So I need to scale that up. So the net is that we're going to be multiplying by 100,000. Do the math here, and you're going to get 2.56 times 10 to the minus 10th liters. And this is another one. Make sure that you go through and account for the fact that I've got 3 tens in my denominator there, and there's 1,000 that I'm going to have here. And then I'm going to have 100,000 in my numerator from there. So we need to make sure that we keep all those pieces together. This last piece is really important because I don't want to know the volume of one cell. I want to know it for 100,000 cells, and so I'm just left with units of liters. So I'll give you guys a minute to finish writing, answer for that, and we'll kind of see where everybody's at. Feel free to unmute yourself if you've got questions on anything. All right, any questions? Are you ready to go on? All right. right, let's go ahead and move on. I'm going to have you guys do this next one by yourself again. I'm going to give you a few minutes to work on it. So we'll come back to this one that's in your textbook, but I want to kind of keep the level maybe the same. So in terms of the number of unit conversions we have. So why don't you guys try this one here? We've got an area of a telescope lens that's given as 7,903 square millimeters. I want to know what's the area in terms of square feet. Unit conversion to give to you is that 1 centimeter, or I'm sorry, 1 inch is 2.54 centimeters. So again, that's one that would be provided. Just so you know too, how I tend to do this is that table of the English to metric ones, I'm just going to project that on the screen tomorrow. So you can pick out whatever you think is helpful for that problem. So the problem will be projected on the screen, and then that table of English to metric conversions will be listed there. And if there's anything else that you need, I'll list it there as well. So try working through this problem. Again, I'll give you a few minutes here. I'll come back a little after 6:25 and we'll check in and see where you're at. I'm going to give you the answers. Oh, actually, I need to finish my math for this. So I'm going to give you the answers in just a second, but let me go through and finish my calculations here. So I'll put the answers up in just a second. So I just put those answers up there if you wanted to check. I'm going to go let you guys work a little bit longer on those problems, and then we'll reconvene. Does anybody want more time? I can see a few people. Raise your hand if you wanted a little bit more time to work. All right, I'm not hearing any requests for more work, so let's kind of walk through this problem and again see if you guys have some questions on it. Not really a picture that we need to draw here, but I guess I'm just such a picture person. We've got a lens, so I got a circle here that's 7903 square millimeters. And my first problem says, I know how many square millimeters that is, but I want to know how many square feet that is. So to make my roadmap, I don't know a connection offhand between millimeters and feet. So I know I'm going to have at least 2 steps. So what I start doing is trying to walk to pieces that will get me some information, get me where I want to go. And the more of these you do, the more you'll sort of just kind of see steps in your head. So one thing that you could do is maybe think backwards and be like, all right, I got to get to feet. Well, I know that there's 12 inches in a foot, and hey, they gave us this 12 or 2.54 centimeters in an inch. So I can go feet to inches, inch to centimeters. Oh, centimeters to millimeters. Yep, I can see that roadmap there. So if you can see it sort of, you know, piece those things together, then you're like, all right, I can go millimeters to centimeters. That's a factor of 10. Centimeters to inches. That's and again, I'm going to call these English to metric conversions, so EMs. So when I make my roadmap, I'm always making sure I put over my arrow in my roadmap the piece of information that's going to allow me to do that unit conversion. And then inches to feet, well, I just know that 1 inch, or 12 inches, sorry. 12 inches is 1 foot. So once I've made my roadmap and then I have things over all my arrows, I have all the pieces together to kind of string my math. So now I'm going to have 7903 square millimeters. I've got millimeters to go away, centimeters to be left. I got my 10 that's going to need to go in the denominator. I have to square that. Now I need to go and have centimeters go away. And inches on top. 1 inch is 2.54 centimeters. So always making sure that we're putting our stuff in the right spot. And now inches and feet. 1 foot is going to be 12 inches. Got to make sure to square that one as well. Looking at my units, millimeters go away. Centimeters go away. Inches go away, and I'm left with the feet squared that I want. So now I just need to go through and do this in my calculator. Something I want to have you guys think about as you start doing things with your calculator. There's 2 ways you can think about putting stuff in here. For some people, what they might find easy is I'm going to multiply everything that's in my numerator together, and I'm going to write that answer. And then I'm going to multiply everything that's in my denominator together, and then I'm going to write that answer. And then I'll divide those 2 at the end. Or if you know how to use the parentheses on your calculator, or if you have one of those graphing calculators, it's easy to just kind of string everything all together. But I could do this where I could say 7903, and then I'm going to say divided by, I'm going to use my parentheses key here because I want to divide by everything that's in my denominator. So I'm going to say 10 times 10 times 2.54 times 2.54 times 12 times 12. So I've got all of that here, and then I'm going to close my parentheses. Because if I just try to type things in my calculator, and in my mind I'm seeing 7903 divided by 10 times 10 times 2.54 times 2.54, if I don't use parentheses, my calculator is going to put some of that stuff in the numerator, which will give you the wrong answer. So I encourage you play with parentheses, particularly if it's a problem that we know the answer that we're going to get because we've sort of played with it a little bit here. And for this problem, math works out to 8.507 times 10 to the minus second square feet. And the only piece of information that we really were given in terms of determining significant figures, had 4 significant figures. So that's why we still have 4 in our answer here. All right. So give me a number. Give me a number on how you're feeling with that problem. Give me a number in the chat.
Dr. Prenti, I have a quick question.
Yes.
Is it okay if we left it in decimal form, even if it had 4 significant figures?
That's fine. Yep.
Okay.
Yep.
Thank you.
You're welcome. Yeah, for the most part, I generally don't care about scientific notation versus sort of standard notation, as long as the significant figures are right. All right, I think people are putting in 8s, 9s, 10s. Good, good, good. All right, the next problem, I'm just going to go through pretty quickly because hopefully as you make your roadmap, you're like, oh, this roadmap's pretty simple. If I want to go from the size and area of this, which is information that's given, to time in seconds, they actually give me a piece of information here, right? I can put this together and say 45 seconds is equal to 135 millimeters squared. Because I have a relationship that's provided that walks me between both of those pieces, this is just a single one-step unit conversion here. So we're going to have 7903 square millimeters. Let me be consistent here. I'm going to put my answer when we execute it in black. 7903 square millimeters times 135 square millimeters can be done in 45 seconds. So we end up with 2.634 times 10 to the third. Rounding and adding units, we're going to have 2 significant figures here because it's 45 seconds is going to limit us. So 2.6 times 10 to the third seconds is going to be our answer. So, and as a heads up, you're going to have somewhere between 3 and 5 unit conversions in the problem that you'll see either on Wednesday or Friday. So if you're doing something in one step, it's probably not the right step. So keep that in mind for the problem that you're going to see in class tomorrow or Friday.
I just had a quick question.
Yes, and tell me who's asking.
Jimmy.
Jimmy, all right.
I actually went ahead and I did it in minutes. Would that be an acceptable answer too, or did you want to leave it?
I'm glad you asked that good question. You might lose a little bit there because you didn't answer the question in the right units. So
Okay.
just make sure that you're always just making sure to answer the question. Now,
Okay.
I'm not likely to be super persnickety because clearly you know what you're doing. I'd probably circle it and just say, hey, make sure that you answer this with the right units. Other questions, comments? All right. I want you guys to do this one on your own. Let's do this one on your own. I'm going to give you about 5 minutes for this one. And let's see where you get. We're talking about a cube of aluminum. And we want to figure out its density. Now, let me get the answer here for you. Oh, I actually have the wrong number in here. I copied my problem wrong. So it's going to weigh, because otherwise we're just going to get a number that won't make sense. It's going to weigh 10.25 grams. All right. How you guys doing? Anybody want more time? Give me a, let me see. I'm going to ask you guys a yes or no question because this is some of the stuff I want to figure out, have you guys do. So figure out how to give me, like, raise your hand, give a blue hand raise if you got that answer. So as a participant. So if you go to the, I think it's under the participants window. If somebody wants to unmute, just if someone isn't able to find where it is, share with your fellow classmates here how to raise your hand. Amber, I see you have your hand up. Can you just share for a second where you found that?
Yeah, it's on the bottom bar. It says participants, and then if you hit that, a little menu pops up, and it's the bottom left-hand corner.
Okay, so hit the participants kind of thing in the bottom menu bar, and then, so I'm seeing about half the people, so maybe, so Jimmy, did you get the answer or no?
After I saw, like, I did, and then once I saw the answer, it, like, helps me, but I kind of want to see how you work it out before I say anything.
Okay.
Because it was kind of confusing.
Okay, so did you or did you not get 2.7?
In the end, I did, but it was a rough road to get there.
Got it. How about Anna, Grace, Caitlin? How about you guys? I didn't see blue hands there. Let me ask Anna first.
Yeah, I put my answer in the chat. When I click participants, nothing like pops up for the menu or whatever. So, but I did get the answer.
Got it. All right, thank you. And I think maybe Grace.
Yeah, no, I didn't get it. I couldn't get it.
Okay. All right. So we'll walk through this one, and then I have one other problem I want to have you guys do. I want to do the swimming pool one, and then what I'll try to do is just maybe post the solutions for the rest of these, so that if you wanted to work through them on your own, I don't necessarily know I'll have a video solution, but I'll just have a static solution so you could sort of see. So with this one, what we're going to have is, this is a little bit of a different kind of a unit conversion problem, because at the end we need to find density. You do need to know that density is a relationship between mass and volume. So if we're going to calculate and figure out density, we need to know the mass of the substance that we have and then the volume that it's contained in. Well, the good news is the mass was given to us directly, and then we weren't given the volume, but we were told that we had a cube that measured 15.6 millimeters on each side. So I know if I've got a cube, I can use a volume equation, which is length times width times height, to give me my volume. And again, it's going to have units of millimeters cubed. And I know that I can get to centimeters cubed by using a relationship that's sort of a tenfold difference. Okay, so I want to pause for a second. I want to ask Vinny, like, are we on the right track from what you did, or what did you do that was different at this point, or not yet? Vinny, was it you that said you wanted to sort of see how things worked out? I'm curious if we're still on the same.
Sorry, yeah, that was me. So I was confused because it said 15.56 on A side. I didn't know like that would be all of them.
Oh, so that's a really good point. How do I know that it's 15.6 millimeters on each side?
It's a cube.
It's a cube. Okay, so sometimes there's like little like nuggets of information that's in the words that we need to use. So yeah, if we have a cube, we know that every side is going to be 15.6. So that is again one of those little tricky things, but working through kind of the math for this, right? I can take and use my volume equation, which is length times width times height. And you'll notice some of the other problems that were on like our worksheet that we had, or some of the other ones that I had out for tonight. If you have to figure out volume of a different shape, I will tell you what the equation is for that. So keep in mind that density is always a relationship between mass and volume, but if you had a cylinder, if I gave you some information about like measurements on the cylinder and I gave you the equation for the volume of a cylinder, you could figure that out. Now, the only one I am sort of expecting that you know is if you have a rectangular or a cube shape, that's always length times width times height. So figure this out for 15.6 cubed. That's going to be 3796.416 millimeters cubed. Now notice one of the things I'm doing here is I am keeping lots of significant figures until the end. Don't round too early because you can sort of have a rounding error that allows you to not get the right answer. So in this case, my next step, I really only have one unit conversion step, is this is going to take millimeters to centimeters. I know it's a tenfold relationship, but my 10 goes with my millimeters. I need to make sure to cube that. And now I'm going to have the volume of this little cube is 3.796416 centimeters cubed. Now, I probably didn't need to keep 7 significant digits, but I'd probably keep 5. And so now I have my other piece that's going to go in here. So sort of pulling this all together now, density is going to be equal to the mass that was given over the volume that I just figured out. That will give me 2.6999 in my calculator. I'm going to have 3 significant figures, so I'm going to round to 2.70 grams per cubic centimeter. So what's unique about a problem like this is sometimes part of the problem is not necessarily just walking through a unit conversion. To figure out the answer for this problem, which was density, we have to know that density is a relationship between mass and volume. So if I can independently get both of those pieces of information, I can get my answer. So mass happened to be given to us, so that was super easy. And then I needed to go through a one-step unit conversion to get to volume after I figured out volume from my length, width, height measurements. Okay. So Vinny, maybe the problem there is, yeah, you were like, I don't know if I have enough information for this because they only gave me one side of it. How about anybody else? Any other questions on that one? All right, we have just under 15 minutes left here, and I want to go through the swimming pool problem. I want to give you guys, I'll probably give you, 7-8 minutes here to sort of work on it. And then we'll wrap up with our last 5 minutes kind of going over that problem. So I'll go ahead and I will put the answer in for you. And I do have to give you a few unit conversions here. So the number of English to metric conversions. Some of them we've used in other problems, so maybe we're already kind of on that path. We're going to assume that the density of water is 1 gram per milliliter. So if you get the answer, give me a little green check mark next to your name, even if it's just for one part. I will tell you this one is more than I would ask you to do for tomorrow. So if you're making some headway on this, you're doing amazing. Awesome. Seeing some green check marks. So I'm seeing responses from a little over half. So what we'll do, since we're getting close to time here, is I am going to go through this problem and then we'll wrap up for tonight. Like I said, I'll try to kind of post solutions for the other problems, but the other problems are, again, some of these more intense sort of challenge problems. So might be a little bit more than you need to be worried about. So I'm going to draw myself a little picture of a swimming pool here, right? Recognizing that my swimming pool is just going to be a rectangle that is going to be 25 meters by 50 meters by 4.8 feet. So we can sort of envision that, right? It's about a 5-foot deep pool, and then it's 25 by 50 meters. So at the end of the day, we want to know how many gallons of water are going to fill that pool, and we want to know how many kilograms that water is going to weigh. Right? And when you do calculations like this, all of a sudden you realize, how the heck can they put a pool on the top floor of a hotel? It's going to be a lot of weight that's sitting up there. So we can take and get the volume here, but right now we can't really multiply just length times width times height, because the problem is they're not all the same units. So the first thing that we're going to need to do is we want to convert this guy into meters, because that way we can get our meters in terms of meters cubed. So even this first little part is going to require a little bit of effort. So the roadmap is going to be, well, let's see. I want to go to meters. Well, I can go from feet to inches, and I can go from inches to centimeters. I got it. And centimeters to meters. The more of these you do, you'll start sort of just seeing these pieces come together. So let's just do this quick little piece here, because we can't even get the volume here until we get everything in our right units. So 4.8 feet, 12 inches is 1 foot, 1 inch is 2.54 centimeters, and then I've got 100 centimeters in a meter. And don't get happy with trying to cube and square things. We're not doing that yet. We're just converting 1 foot into meters. So I've got 1.46304 meters. Make sure your answer makes sense. All right, meter stick, if I've got 1.5 meters, all right, that's about 5 foot. That still makes sense. So now I'm going to have 1.46304 meters. All right. I got that down, but let's see if we can sort of figure out these two different roadmaps for the rest of this. Let's do the gallon one, okay? So this is going to be A and B here. Let me figure out my roadmap for gallons. Well, we just said length times width times height can get me to meters cubed. I need to get to gallons. All right, well, let's look at this information that Dr. Perini gave us up top. Do I see anything that has meters cubed? No, but I see stuff that's maybe, if I can get to centimeters, all right, because one of the things that she didn't write up here that I know is important is I can go from centimeters to milliliters using sort of that magic 1 centimeter cubed equals 1 milliliter. Meters to centimeters, that's 100. All right, now I'm at least in units that are liquid volume. All right, milliliters. Well, I can go from milliliters to liters. That's a factor of 1,000. Oh, they gave us that liters to quart piece. And now I can go quart to gallon. Wow, that's a lot of unit conversions. But hopefully, you know, you start stringing these pieces together. You can see these puzzle pieces sort of come together. And I'm not going to write over top of these, but this liters to quarts is an English metric conversion. Quart to gallon, again, that's an English metric one. I'd give that to you. And then these other two are prefix conversions. All right, so let's go through and put all of this together. Let me do my volume. And again, this one's an involved problem. Length times width, you are not going to see something that has this many steps. You might see like a little facet of this problem. But length times width times height is going to tell us that now we've got 1828.8 cubic meters. So that's going to be my starting point here. 1828.8 cubic meters. I've got to go from meters to centimeters. My 100 goes on top, and I need to cube it. Now I've got that magic 1 centimeter cubed to 1 milliliter that allows me to change from my volume that I measured in length to my volume that's measured in a liquid measure. I want to go from milliliters to liters. So my 1,000 goes on the bottom. And now liters to quarts, that was one that was given to us. 1 liter is 1.057 quarts. And I've even run out of room here. So now I got to keep going down on the bottom here. If I've got, I'm to quarts, so I want quarts to go away. 4 quarts is 1 gallon. Wow, that was a lot. But I'm going to end up getting, when I round to significant figures, 4.8 times 10 to the 5th gallons. I'll give you a minute to write if you didn't have a chance. Vinny, it looks like your head's hurting. That one was rough. But this is sort of like the one that we did when we did like how old is the universe? It had a lot of pieces to it, but we just, that was just time and we sort of marched through it. So this one, like I said, there's more steps than I would ask you. You're not going to see a problem like this tomorrow, but for those of you who had a green check mark, that's awesome. I don't think you'll find tomorrow's problem to be challenging. If you find this one challenging, but you're like, you dragged me through it and I sort of got there, you might be okay tomorrow too. I'm going to pause for a second there and let you guys ask questions. Anybody have any questions? I want to respect your time here, and my kids are starving. David just came in here, and I think he's like, when are you getting us dinner, Mom?
I was going to say that.
You were going to say that? Well, you got to come say hi to class first.
I wasn't going to say that.
Oh, you weren't going to say it? You got to come say hi.
I'm hungry.
I know. I'm hungry too. You can come say hi.
Hello.
Isn't this amazing? We're figuring out.
Your video's on.
Oh, my video's not on. You're right. David knows. David zooms into his classes.
Hello.
There we go. We're figuring out how many gallons are in an Olympic-sized swimming pool. It's fun math.
I should just go to the dad's house and figure that out.
All right, I'll be down in a minute to get dinner, all right?
Okay.
So let's just write out the roadmap for what we'll have for this next one. And then you'll see we're sort of going to undo some of the steps that we just did with this problem, because I'm going to start with gallons here. So we want to get to kilograms. So I can go from gallons to quarts. I can go from quarts to liters. I can go from liters to milliliters. And then I can go from milliliters to grams using my density. So let me go in and kind of put these pieces together. Gallons to quarts was undoing my English metric. Quart to liters was another English metric. Liters to milliliters, that was a factor of 1,000. Milliliters to grams, this was going to be my density. So I can use my density piece to sort of get to grams. And then once I'm in grams, I can go to kilograms. That's going to be another 1,000. So I think sometimes half or maybe even 3/4 of the battle here is just figuring out your roadmap. And that's why I will always write roadmaps out, because it helps us sort of plan and see how we're going to execute our steps. And so many times you're going to have just a unit conversion. You'll just, be given. You just need to know how to use it. Density is like this nice walk between volume and mass. These unit conversion ones, those are going to be ones flipping back here, right, that we want to make sure that we know these guys. Okay, but if we put all of these numbers in here, if I start with the 4.8 gallons and I kind of walk through here, you'll get this answer that's up here. Now, you might also ask the question, if I got to, you know, I could start from the same problem here and I could say I'm going to go to milliliters here and then I'm going to diverge and go up to grams and kilograms. I could essentially start my same calculation that I had from the first problem, and then once I got to milliliters, then I could diverge and do these last two pieces. So you didn't have to start from the ending point from part A. You could have, you know, started from the same starting point and then gotten to milliliters and then gone up. So again, this was intense. If you followed me through this one, you know, I think you know enough to be really good tomorrow. Again, you're going to see somewhere between 3 and 5 steps. You want to make sure you know your prefix conversions, and just ask yourself at the end, does this number make sense? All my problems are real problems, like this problem. So you shouldn't be getting something that says you've got a gram of water in the swimming pool. Right? That doesn't make sense. So your numbers should make sense. And if you get an answer and you can't figure out where you went wrong, write on the problem, say, this doesn't make sense, but I don't know where I messed up. And you'll get more partial credit because you at least recognize that something's not right. All right? Everybody good? All right, how many of you, give me, I'm gonna look in the chat or the participants really quick. I don't have a way to like lower everybody's. If everybody goes and like gets rid of your yes or no or hand raise, just give me a little hand raise if you are with me in class tomorrow, if you're a B student. Okay, so a good number of you are B students. Okay, so I will see you then tomorrow in class, and hopefully everybody's good too with how to take a picture of whatever you're going to submit for work then tomorrow. All right? See you guys. Thanks for sticking with me. Have a good night.
See ya.
All right, we'll see ya.
Thank you.
You're welcome.